Hello, in this lesson you will learn how to identify limiting and excess reactants in a chemical reaction. Now whenever the question asks you to identify the limiting or excess reactants in a reaction, what we usually look at is the mole ratio. So for example, in this question here, you are given a balanced chemical equation. Nitrogen gas react with hydrogen gas would give you ammonia gas, and this is a balanced chemical equation. And then in an experiment, 2 mole of nitrogen reacts with 4 mole of hydrogen. So this is in theory. How in theory it says 1 mole of nitrogen reacts with 3 mole of hydrogen. In theory. In an experiment, 2 mole of nitrogen and 4 mole of hydrogen. So okay, you have to write down, you have to compare the theory and actual. Okay, so in theory, this is what happened. 1 mole of nitrogen reacts with 3 mole of hydrogen. Now in actual case or in reality, okay, that means during experiments, 2 mole of nitrogen react with 4 mole of hydrogen. Now in theory, 1 mole reacts with 3 mole in theory. Now how about in theory, 2 mole of nitrogen would react with how many mole of hydrogen? Now in theory, 1 mole react with 3 mole doesn't mean that there can only be 1 mole of nitrogen reacting with 3 mole of hydrogen. Now what if instead of 1 mole of nitrogen react, what if I have 2 mole of nitrogen? So 1 is to 3, so 2 would be to 6 mole. So in theory, if I have 2 mole of nitrogen, I would need 6 mole of hydrogen to react. Let's compare this with this. In actual, 2 mole and 4 mole. Now the question is 4 bigger or less than 6? 4 is obviously less than 6. Therefore, your hydrogen is your limiting reactant. Okay, so your limiting reactant is hydrogen gas. And of course, if your hydrogen gas is the limiting reactant, your excess reactant would be nitrogen gas. Okay, so basically we compare actual and theory. These two rows are theory, this one is actual. Now let's look at the second example. The second example, same thing, same chemical equation given to you. Now in an experiment, 24 dm cube nitrogen reacts with 96 dm cube not mole. Okay, there is a mistake here. Reacts with 96 dm cube of hydrogen. So same thing, we have to look at the mole ratio. In theory, same thing. In theory must be based on the chemical, the balanced chemical equation. 1 mole of nitrogen, 3 mole of hydrogen. Now in actual, you have 24 dm cube of nitrogen. 24 dm cube. Now 24 dm cube is how many mole? We know already 1 mole of any gas, the volume is 24 dm cube. Okay, so therefore this 24 dm cube is actually 1 mole. Let's look at hydrogen. Hydrogen, we have 96 dm cube. How many mole is 96 dm cube? 1 mole is 24 dm cube. 96 dm cube would be 96 divided by 24, and which is actually 4 mole. So now it's the time to compare. For every 1 mole of nitrogen, the theory says for every 1 mole of nitrogen, you need 3 mole of hydrogen. Now, in actual case, in reality, 1 mole of nitrogen, you have 4 mole of hydrogen. And 4 mole of hydrogen is more than the 3 mole of hydrogen in the theory. Therefore, your hydrogen is excess reactant. So your hydrogen is your excess reactant. If one is excess, the other one must be limiting. Okay, so again, every time I compare the actual and the theory, actual and the theory. If actual is more than theory, excess. If actual is less than theory, limiting. Now let's look at the third example here. Now in the third example, same thing, same chemical reaction. So instead of giving you the volume, I give you the mass. So you have 56 gram of nitrogen gas reacts with 6 gram of hydrogen gas. So same thing, we look at the mole ratio. So in theory, 1 mole of nitrogen, 3 mole of hydrogen. In actual case, you have 56 gram of nitrogen. Now 56 gram of nitrogen is how many mole? So it must be the mass divided by the MR. Mass, which is 56, divided by the MR for nitrogen. What is the MR for nitrogen? Nitrogen is N2. So you just have to look it up in the periodic table. N is actually the top number is 14. The AR for nitrogen is 14. So for N2, there will be 14 times 2. And if you do the calculation, you'll find that this is 2 mole. Okay, likewise for hydrogen, it's given that you have 6 gram of hydrogen. So 6 gram here. Same thing, 6 divided by the MR for hydrogen. Hydrogen is H2. Okay, this 3 is not part of the formula for hydrogen. So when you want to find the MR for hydrogen, you don't take this 3 into consideration. Okay, the MR for hydrogen is H2. H, the AR is 1, H2 is 1 times 2. So 3 mole. Now you have to compare the theory and the actual. Okay, theory says 1 mole of nitrogen, you need 3 mole of hydrogen. Okay, in actual, 2 mole and 3 mole. So like this is like comparing apples and oranges. You have to make this into 2. Then you can compare it equally. So every 1 mole you need 3 mole. So that means if let's say you have 2 mole of nitrogen, then you would need 6 mole of hydrogen. Okay, these two statements are the same. 1 is to 3, 2 is to 6. So you have to compare this and this. 2 mole, you need 6 mole. But in actual, 2 mole, you only have 3 mole. So this 3 is less than 6. Therefore, your hydrogen is limiting, not enough. Your hydrogen is limiting. When your hydrogen is limiting, your nitrogen is the excess. Okay, so you are comparing this one and this one, theory and actual. Now let's look at the fourth example. Now the fourth example is slightly different. It's a different chemical reaction. Okay, but it's the same thing in an experiment. 40 gram of calcium reacts with 63 gram of nitric acid. Your nitric acid is your HNO3, your calcium is your Ca. Same thing, we look at theory. So in theory, 1 mole of calcium, you need 2 mole of HNO3 or nitric acid. Now in actual, that means in the experiment, you have 40 gram. So every time you change it to be into mole, 40 gram of calcium, how many mole? So 40 gram divided by the AR for calcium, and AR for calcium from the periodic table is 40. So it's 1 mole. Okay, likewise for nitric acid, you have 63 gram. 63 gram of nitric acid. What is the number of mole? Same thing, the mass divided by the MR. Now MR for nitric acid is HNO3. So H is, the AR is 1, N is 14, O is 16, but then there are 3 O. So it's like that. And if you do the calculation, you can find that it is 63. I mean the denominator is 63, so it's 1 mole. So 1 mole, 1 mole. Now theory say 1 mole, for every 1 mole of calcium, you need 2 mole of nitric acid. But in actual case, 1 mole of calcium, 1 mole of nitric acid. So you are actually comparing this and this. So from here we can see that actual case, nitric acid is less than the theory. When the number of mole of nitric acid is less than required in the theory, that means your nitric acid is the limiting reactant. So your nitric acid is your limiting reactant, and of course your calcium would be the excess. Okay, again, if in order to find out whether you really understand excess and limiting reactant concept, you can download the worksheet that accompanies this video. The name of the worksheet should be the same name with this video, how to identify limiting and excess reactant. And when you are doing the worksheet, if you encounter any problem, you can always refer back to this video for answers. Bye bye.